So let's begin with today's talk. आज हमारा target और aim क्या है? Like a previous sections we have already discussed about many applications related with the different kind of a bridge applications. So among them, the most important task is one that we have to find out unknown inductance or resistance. This is what our target. This is exactly we are looking for, and this is our target. What we have to do? We have to find out unknown resistance and inductance. So here in all these cases, we are trying to find out how we can go for to find out the unknown inductances and reactances. So among them, we got that different kind of yeah the different kind of bridges are there that help us to create such kind of circuits that if one of the branch is unknown and rest three are known, then we can easily find out the remaining one. जो पता नहीं है, we can easily find it out. So this is what exactly the process we are using. So under the series, all the bridges are based on a single one concept. What is that? That concept is nothing but simply is called as a Wheatstone bridge method. So under this Wheatstone bridge method, simple concept, when the bridge is here and during that particular bridge, three branches are known, one is unknown, then with the help of getting the ratios, one can easily find out the other. अब इन्हीं में कुछ improvements किए गए. Every time we have just created some sort of the improvements. What are those improvements? The improvement is that we are developing such kind of a bridges which are helpful in efficiency and in losses. So in the same section, if we see here, we read it out, we find out that under the bridge conditions of this one, we are having this new one. If you see here, we find out that this is one. So here we have this Anderson bridge. What is the difference in the Anderson bridge as compared to previous? We've already talked about Maxwell and the Hayes. So in comparison to Maxwell, in comparison to Hayes bridge, we have here something additional. What is that additional? That is additional we have here. If you see, under this situation, we have this capacitor, resistor, inductor, resistor, and the resistor. So additionally, this capacitor is being made. So if you just go here, you find out. So with the help of this bridge, one can easily find out the inductance of a coil. Or inductance पता चल गया. So with the help of this, one can easily find out what else. Other than this, one can easily find out the in reactance. XL आप लोगों ने पढ़ा होगा 2 pi FL. One can also find out the value of the 2 pi FL. So 2 pi FL से XL भी निकल सकता है. So one can find out the reactance also, and as well as one can find out the value of inductance. L भी पता चल सकता है. So under this situation, if suppose we are looking to find it all out, so we can get a basically an idea how we can go for. So here we are using some application part. What is that? Apparatus we require. The apparatus we need simply resistance box, capacitor, headphone. पिछली बार भी हम लोगों ने headphone का example लिया था. Either we can have the galvanometer or we can have the headphone. So the headphone and the galvanometer both can be taken up here. दोनों में से कुछ भी लिया जा सकता है. ठीक है. Now if we see this bridge is very same. वहां पर इंडक्टेंस और रेजिस्टेंस लगे हुए थे सीरीज में, यहाँ पर सिर्फ एक कैपेसिटर बनाया. So if you see, the AC bridges are often used to measure the value of unknown impedance and inductance, capacitance of a capacitor accurately. A number of AC bridges are available, and Anderson bridge is an AC bridge used to measure self-inductance of the coil. It is a modification of Wheatstone bridge. Wheatstone bridge में हमने modification किया है. It enables us to measure the inductance of a coil using capacitor and resistor and does not require repeated balancing of bridge. Most important, क्या different हमने यहाँ पे लिया? The different part we have here that in this one we have basically we do not require the repeated. हमें बार बार उसको set करना नहीं पड़ेगा, adjust नहीं करना पड़ेगा. The bridge is balanced. Bridge balance हो जाता है. कब balance हो जाता है? By a steady current by replacing headphone H by moving coil galvanometer. तो कुछ लोग हेडफोन लगा लेते हैं और कुछ लोग गैल्वेनोमीटर कॉइल लगा लेते हैं. इट्स नॉट अ बिग थिंग. हेडफोन से भी स्मॉल आपको साउंड सुनाई दे सकता है. दैट्स लाइक एन हेडफोन. और इसके अलावा अगर आप बेसिकली ब्रिज यूज करते हैं, आप गैल्वेनोमीटर यूज करते हैं, तो डिफ्लेक्शन. ठीक है, तो नॉट अ बिग. This is done by adjusting the variable. So what we are doing? Headphone, moving coil, galvanometer, AC source by a battery. This is done by adjusting the variable resistance. अगर आप यहाँ पर देखेंगे, if you see here, here we can find out this variable resistances. So these are the basically the variable resistances shown up here. तो यहाँ पर हमें variable resistances दिखाई देते हैं. And when we have this variable resistances here, then we can say under this variable resistance situation, we can change up. So the condition for the balance is that potential at the terminal D. So if you see the bridge condition here, so under this bridge you can find out like I'm sharing it again. Visible, it's yeah. So if we see here, if this bridge condition is here, so under this bridge condition, some resistances are here, which is the first part. Second resistance is here. Third, if you see here, arrow, this arrow is indicating that here we have variable resistance. So हमें सिर्फ इस variable resistance को ही tune up करना है, ठीक है. So the base is balanced by steady state current by replacing the headphone. H और वो आप लगा सकते हैं यहाँ पर, दोनों conditions available है. The condition of the balance is the potential at the terminal D and E. We have D and we have E. is the same as the current flowing through branch AB is I1. तो यहाँ पर जो current है, यहाँ पर जो flow कर रहा है, और ये जो current I1 flow कर रहा है, that has to be same one. Through balance AB is I2. The current flowing through branches AD and DC is I3, while that branch DC is I1 plus I2. DC branch में अगर हम बात करते हैं तो दो का सम आएगा. DC it is I1 plus I2. A to B, this is the current I1. Here the current is I2. Here the current is I3. So all the current are mentioned. तो यहाँ I1 plus I2 plus I3 flow कर रहा है. Here we have the I1 plus I2 plus I3. So three current components are being shown up here. तो अगर हम इसकी मैश इक्वेशंस निकालें, इफ वी आर लुकिंग फॉर द केसीएल, आप लोगों ने पढ़ा होगा. सो इफ यू सी केसीएल इक्वेशन, सो I1 into P, I1 I2 into Q minus I3 into J L omega plus S minus I3 R equals to 0. See what is happening here in this particular equation. We are simply balancing. अगर हम एक मैश ले लेते हैं, in the mesh we are balancing all the voltage. So this Q is the resistance of this one, okay, and here I3 has this resistance R plus this one, and what we have else taken, we have just taken this I1. So taking this one, this whole one, पूरा का पूरा हमने बड़ा वाला बॉक्स लिया है ना, A B C D A, complete box. So if we see here, one potential drop is here, second potential drop is here, third potential drop is here, fourth potential drop is here, and we know that the sum of all potentials in a particular, किसी भी अगर हम मैश में बात करें, the sum of the all potential in a particular signal, then it equals to 0, because जितना voltage drop होगा उतना ही आपको add up होगा, so that becomes 0. So that's why the sum has been taken as I1P. I1P, it means this I1 and the resistance P. The voltage drop we are getting I into R, V equals to IR. And the current direction is same. So that's why the second is taken as I1 plus I2 into Q. This plus this. Finally, moving ahead, coming up this, if we see the direction of current is opposite. Here the direction of current is opposite. So that's why I3 into R plus. So this is the R, which is S. So S plus, and what we know, what is the reactance of inductance? That is J omega L. So we can write that J omega L minus I. Simplifying all these one here, on simplification, we are able to get this equation of our I2, and finally we are going all these calculations, same calculations are there, and using the equating values, one can easily find out the net relationship among them, which is coming as the XL equals to 2 pi FL, and L can be calculated through CRP plus 2R. So with the help of this relation, one can find out the value of unknown inductance. So what we have to take care? We have to take care about this relationship which is coming from all these equations and calculations by equating them. So we do not have a target to just go for the mathematical calculation right now because it's not theoretical part. Here we have only the target that we must have this relationship so that we can find out. So this is basically the system. Let's see what will be the process, how we are going to this one. So this process would be understood if you see here under this one, we have just made all these kind of a battery combination is this one. So under this situation, we are creating this all Anderson bridge, voltmeter, these are the resistances box and everything is there. Here we are getting this bridge setup is there. This setup has been taken up. Okay, so now what we are doing in this first one, we are making a connection, simply connection, and here we are connecting the galvanometer. So one, two, three, four. Four resistances and one battery. It's a very simple one. This is a VG Stone bridge diagram. In the second, what we are creating? Anderson. Now we are creating the Anderson. So one, two, three, four. Four resistances are here. And it being that, as we have seen in the previous diagram, if you go back, you've just gone through that one, two, three, four. Four resistances are there, but need to have one resistance, inductance, and second, what we need to have one capacitance. So that's why under this one, this has been taken. So one, two, three, four resistances, and additionally, what we are adding up? We are adding the one capacitor and the one inductor. That is what the capacitor and the inductor has been created. And now we are adding this galvanometer as same. So we are having the same galvanometer, no issue at all. We can connect on. So what is the process? Process is very same. If we go through this one, so what we are doing? We are having a first of all signal generator. So we are having voltage, frequency, diameter, power on button is here, variable resistance R is here. So small r is nothing but variable resistance and resistance boxes. All this one here. So steps, procedure for doing simulator. Connections are made using the connection diagram. So you just made the connection diagram. Okay. Then what we are doing? We are creating power on the switching signal generator. Power on किया यहाँ पर. Then we are creating a power. Okay, we are providing the second step. Applying particular voltage and frequency, because if suppose we are providing the power, that means we are giving signal to it. That signal has a voltage, amplitude, and frequency. So we are providing this voltage and amplitude and frequency. Next, particular length of the inductor coil and diameter. We have this inductor because this is a variable inductor. So this variable inductor can be changed through its length. That can be changed so that it becomes unknown. Then what we are doing? Giving a particular resistance, P resistance box. Among them, we can change the resistance, and once we get the value 0 here, we find out all 1, 2, 3, 4 values. By dividing and getting the equation, one can easily find out. So see what they are doing in table. They are finding R, they are finding Q, they are finding resistance P, they are finding variable resistance S, they are finding variable resistance small r, and finding L. And using this formula, what we have discussed earlier, and one can easily find it all. So I hope so you might be able to understand. This is a very simple experiment. 4 resistances को use करना है, 4 resistances के साथ में एक inductance series में लगाना है, capacitor लगाना है, और we have a known values. Inductor is unknown. Just get the values, balance the bridge to make the zero position, and just note all values. Put the formula, you will have the right answer. This is exactly the need. So I think so you might be able to understand this basically lab system. Let's check it out. So first of all, we have here the Anderson bridge. We have same one. See, this is the Anderson bridge we have already talked about. Here we have the resistance. Here we have basically the variable resistance. Here another resistance, the capacitance that can be changed. The capacitance is here that can be changed. So all the conditions are very same as we have. So here we have all the decade resistance or inductance box. It means by this you can easily choose. By then you can easily choose what you can want to add here. What do you want to seriously want to add here? And you can have, like they are having also the CRO facts. उनके पास CRO भी है. They are connecting with the CRO facts too. They are just moving up here, and you can easily find out the signal. You can also easily find out the signals on the CRO. So they can connect the CRO also. Let's see signal आया कि नहीं आया. अगर वेव है इसका मतलब समथिंग करंट इज देयर. ये विजुअलाइजेशन तो और भी अच्छा है. one can easily find out. So see here how we are doing it up. So here we have all the resistance that can be changed with the help of this one. We have a decade box simply, and see here we are connecting that, basically the oscillator, we are providing an input to it. On these two terminals we have just given an input, and then we can easily put a variable node. We can change it up here. Here in the point we are connecting the value which is basically the unknown one. So that is now connected. So that connections are very same. It's not tough. Once you see this particular, you would be easily able to understand. These are just only the connecting leads. Connecting 1 and 2. Connecting one by one, and then you can take. Now connecting this one from this decade box. If you see here, completely it is mentioned. Here we have a decade inductance box. And that is being connected here. So this is basically all connections. And connections are same. It means you have basically resistances, you have inductances, you have to connect. अब अपनी तरफ से choose कर लीजिए. You just choose it all. Whatever you wanted to connect up here, you just choose this one. That is what exactly they require. That all done. So we have just connected this one. Once the connections are being settled up, all the connections are being settled up, then we have a target to all adjustment. So now these connections, after these connections, with the help of this, one can easily choose a different decade. Like the different decade, it means a different value of inductance that is known to you, and you just verify whether the bridge is giving the right values to you or not. आपको सही value दे भी रहा है या नहीं दे रहा है. So if you see here, now the signals is coming. It's not the balanced situation. The signals are coming up here. Okay. Now what we have to do, आपने कुछ inductance set कर दिया. अब आप अपने resistance को tune कर रहे हैं. See, it's very interesting. It's very simple. You just doing nothing, connecting and tuning. So now you are tuning your resistance. If you see, amplitude is getting down. You see here, this amplitude is getting down and almost it becomes nil. Now you say this situation has called as balancing situation. If flicks are here, you just do better. Like more effective balancing of this particular has been made. That we are doing here. That is done. Now the bridge is balanced. When the bridge is balanced, you can find out all the values, remaining values of the resistance, capacitance. And once you have all these values, you have a formula that we have already discussed. With the help of that formula, just calculate the unknown impedance. So see how much simple and easy it is. If suppose physically you have this slab in your hand, so hardly it takes only 5 minutes to just get all these values. Just connect it, adjust it, and find out the zero readings that we have already gone through. If you see here, no fluctuation. They are having a CRO. We can also connect the CRO. We can connect the headphone. We can connect the galvanometer. Whatever the requirement is there, you can connect your own things. You can choose your own one. That's a very simple process. And by this, you get the unknown value. So this is basically the motive of today's lab. I hope so you all might be able to understand what is basically the Anderson bridge and how it is different. It has a very easy tuning as compared to Wheatstone based on resistances. If suppose we are using the number of the resistances drop some voltage in it, and because of that drop, power losses are there. So always using a kind of a device who absorb power is not good always. So what is good? The better thing is here, we should use such kind of a device that should not drop losses. So that's why we are just putting some improvement. So first improvement we made in the Maxwell, connected only inductor. Then we made another improvement. We used an inductor with respect to the connection with the series of a resistor. Then in the third case, which is the third lab condition, we have just made another improvement. And this improvement is nothing. We are using a capacitor also. So using this kind of a device help us to improve efficiency of a bridge. This is the way. So this is exactly the today's lab. I hope so you'll be able to understand better to write, better to create, and complete this lab properly. Share your manuals. Okay. Thank you.